Chapter 3, Phases of Matter. Matter and Energy, Section 1. Let's review a little bit. Matter is anything that has mass and takes up space. It can be a pure substance, which is an element or a compound. Or it could be a mixture, a homogeneous or heterogeneous mixture. It's made up of atoms and molecules. And this takes us to kinetic theory, which is the ability to change or move matter or do work is defined as energy. And kinetic theory deals with that energy of motion. So kinetic energy is just the energy of motion. And that theory of matter just tells us that all matter is made up of atoms and molecules. And those atoms and molecules act like lots of tiny little particles, but they're always in motion. If we get to the point that we can slow them down to stop them, we've reached that point of absolute zero. So here we have a diagram. It shows those molecules are constantly in motion. Because all particles of matter are in motion, they have what we call kinetic energy. The higher the temperature, the faster the particles move. At the same temperature, though, the more massive particles have a tendency to move slower than the less massive ones. The smaller particles move faster. Particles of matter are constantly moving, but they don't all move at the same speed. Therefore, some have more kinetic energy than others. Temperature is the measure of the average kinetic energy of the particles in an object. So remember, we just said that those heavier particles move slower than the smaller particles. So the temperature is just that measurement of the average of all of those particles in a given sample of matter. Thermal energy is the total kinetic energy of the particles that make up the entirety of the substance. So temperature versus thermal energy. Thermal energy is the total, but temperature is the average. Thermal energy is determined by the amount of the substance. So a cup of coffee would have less thermal energy than a pot of coffee, simply because of the amount of coffee you have. Our phases of matter shouldn't be anything new to you. We classify matter as either a solid, a liquid, or a gas, or even a plasma. This is determined by whether or not the shape and the volume are definite or variable. Our solids are atoms and molecules that can only vibrate in one place. They occasionally slide past one another, but it has a very rigid shape. We compare this to students in detention. They can fidget in their seats, but they can't get up and walk around. The shape is definite. Those students in detention, they're sitting in an assigned seat. They can't just move their seats around. And their volume is definite. We know how many people are in there. Their energy is low. And they have what's called a crystalline solid, which is just atoms arranging in a regular repeating pattern. We see that with water forming ice cubes. We see that with salt forming crystals. We also see it with diamonds, which is just pure carbon repeating itself. We also have a type of solid called an amorphous solid, and it just has no repeating pattern. And this is going to be like your wax or glass. We know that glass is a solid, but we also have proof that those molecules are still moving, because if you look in a very, very old house, a lot of times the panes of glass will be thicker at the bottom than they are at the top. And that's because those particles that make up the glass over time has shifted, and gravity has pulled some of those particles down towards the bottom. Next, we have a liquid. These atoms and molecules can move about freely. So, for example, students in the cafeteria, you can get up, you can take your stuff to the trash can, you can come back, you could even move to another table if you'd like. So our molecules move about freely. They have a variable shape. So depending on what room we put you in, students take on different shapes. The volume is definite, so that doesn't change, and the energy is considered mid-level. Liquids have what we call surface tension, which is what allows that little water bug to walk across the surface of the water. And this is simply the attraction of the molecules at the surface of the liquid. It causes liquids to form spherical drops when they fall. And then we also have the term viscosity, and this is just the resistance to the flow of a liquid. If it has a low viscosity, it's very runny, like the water in the picture. If it has a high viscosity, it's much thicker, like honey. You'll sometimes hear talk about viscosity when they speak about motor oil. Next, we have gas. Those atoms and molecules are moving around wildly, constantly running into one another. For example, football or even volleyball practice. The balls are bouncing around, students are running around. It's kind of a controlled chaos, and that's the way that the gas atoms and molecules are acting. Their shape is variable. They're going to expand to fit the shape of the container that they're in, and their volume is also variable. Their energy is high. They are moving the most, and because the particles and liquids and gases can move past one another, they're considered fluids. So a fluid is anything that we can pour, anything that flows. Next, we have plasma. This one might be a new one. It is the fourth and most common phase of matter in the universe. Its shape is variable, its volume is variable, and its energy is the highest. It sounds a lot like a gas already. The particles are electrically charged, and it is affected by magnetic fields. So plasma is found in the atmosphere, it's found in space, but it's also found in places here on Earth. So plasma acts like gases, but there are some important differences. It can conduct electricity. So gases, the air around you, doesn't conduct electricity, but a plasma could, and that's what's responsible for the northern lights or the southern lights. It's also commonly found in stars, but we can create it naturally on Earth and in the very hottest part of the flame. So we will find lightning on Earth is a source of plasma, but there are also plasma welders.